Good morning. Welcome to my talk. I'm very happy to be here. It's my first time at Vox Days Zurich, and I want to talk about a very sad topic. We need to talk about documentation. But I want to show you some ideas. I want to share some of my experiences so that maybe we can make documentation great again. And I will talk mostly about software architecture documentation, but many of these ideas we will discuss here are also valid for every documentation you have to do for your software projects. Yeah, let's start with a few words about me, why I'm here. That was me about 35 years ago, when I was maybe 10, 12 years old. And back then I was thinking about what could be my job when I'm an adult. And I looked at my family members, and my grandfather impressed me the most. He was an architect. Of course, he was not a software architect, he was an architect for buildings. And so that was the reason I studied civil engineering in the late 90s, but never worked as a civil engineer. I worked for 15 years as a software developer, and now since 5 years I'm with Embark. It's a German software architecture consultancy company, and now I'm allowed to call me a software architect. So my grandpa already died, but maybe he would be very proud of it, but he won't know the difference between software architects and building architects. I'm also part of the Java community, so today we talk about documentation and software architecture, but I'm also a real big fan of Java. I'm a member of the Java user group Darmstadt, that's near Frankfurt in Germany. If you are around the Main-Rhine area sometime, please join us. We have regularly talks each month. So today, but I can't be there today, so a friend of mine will be there. And there's an online community, it's called Cyberland. It's kind of subtype of JavaLand community. And we also regularly organize online conferences. At the moment, we have monthly open source code camps, so it's quite easy to get started. You can just join remotely, and we just hack some open source projects together. Okay, that's it. Let's start with what's the problem with documentation. I already said it's maybe a bit a sad story. And I think we have lots of excuses if it comes to we have to write some documentation, maybe for software architecture or what else. Reasons are very different, but maybe it has something to do with we don't use the right tools. We have to change applications from our development applications, IDEs, to something in the browser or to some WYSIWYG tools like Microsoft Word or whatever, or we have to put our results on the file sharing, which is also not quite nice to do. Maybe we have lots of redundancy in our documentation, or we have many text and that's not nice to read. Maybe we have to do lots of manual work to create our documentation results. Maybe we need different results for the developers, for customers, for different stakeholders, and then always have an outdated documentation and nobody reads it anyway, so maybe that's not maybe it's also quite frustrating. But there are lots of good reasons to have a documentation, especially for software architecture, that helps us, it supports us with designing our architecture. It's also quite important to have a documentation as the base for some fundamental for communicating the ideas of our software architecture to the other stakeholders. We could also need some documentation for architecture reviews, for evaluating our systems. And maybe in a few weeks or months or years, we ask the question about the why, and then we maybe have a better answer than it's historically grown. And we always will get some new colleagues, and it's a bit easier for them to to get involved in our project. So let's see how that would work, that we can can use all these advantages, but also find some ways to document more. And a friend of mine, Ralf Müller, and me, we created kind of a maturity model about docs as code. So we will talk about docs as code now. And yeah, the maturity model, it starts with the we call it conventional documentation. Maybe we already have kind of standard structures like ARC42, C4, or maybe you are using ADRs. But yeah, it's demotivating to write documentation at all. So we should have a look at maybe some fundamentals for Docker code, like using a lightweight markup language. We come to that back in a few minutes. We could also use a better, or should have a more efficient handling of using graphics, diagrams, images. We should also try to integrate our work in the tooling we are already using. We should continually improve our documentation. And the tip of the iceberg is to harmonize our documentation and make it more lively with the implementation. I will talk about that a bit in the end of the talk, but yeah, let's come to that in 30 minutes, about 30 minutes. Let's start with the lightweight documentation and how could documenting become more attractive. And our daily bread and butter, I think most of you are developers, is of course that we are used to work with plain text. We are using tools like IntelliJ or Visual Studio Code, our IDEs. We are using command line tools, lots of automation, build management, and we of course use version control systems. And documentation as code builds on that fundament. So we have lightweight text formats, Markdown, AsciiDoc, for example. We stored it in the file system, so it's quite easy to search for informations, for example. We can just use the command line tools for that. We, of course, use a version control system where we, for example, a Git repository, where we can just store our files and we can let's see what's the difference to an older version, or we can just have a history of our documentation. Git, for example, is also offline capable if we have to use it in the German trains, for example. Not in Switzerland, but in German trains, we don't. You never have internet access, so maybe that's also a good reason. And we can easily integrate our documentation processes in our build process. So if we already are using Maven or Gradle, it's quite easy to just also integrate the generating of our documentation in that processes. So we have kind of continuous creation. We'll talk about that later. And we can, of course, generate some of the contents for our documentation, maybe from the source code, maybe from data models, maybe from UML models, and so on. And also very important is that we can modularize, decompose our documentation, so we don't need to have one big file, 50 or hundreds of pages in Microsoft Word. Everybody who maybe used it for a bachelor thesis or something like that, he knows that Microsoft Word is not made for such big documents. And maybe of course, we have different stakeholders and we need kind of flexible output, and we will see that it's also quite easy with documentation as code. Let's go to point 8, that's the modularizing part. And if we use AsciiDoc or Markdown, I think I don't have to talk a lot about Markdown, AsciiDoc. We come to that back in a few minutes. But if you use already AsciiDoc, then you can have kind of master document. Here with ARC42, I will also talk about that in a few minutes. And then we can just include our chapters. So we have one file for each chapter. And these can also include some images, for example, or maybe include some code snippets, or which are only a reference to the actual code, which is maybe in the same GitHub repository or Git repository, or maybe in another Git repository in the same file system. And we can also have some sub-includes chapter 8.1, for example. And for the different stakeholders, maybe there's a kind of business master for our customers, which only needs chapter 1 and 2, or we have a security master, which only needs these special chapter 8.1, for example. So it's quite easy, and we are already used to decompose a lot, because our software applications, our software architecture is also based on a decomposition in smaller parts, in components, in building blocks. So why don't we use it also for documentation? And it's easy. You can just use the file system. You have some text files. You can use a text editor, or of course the IDE. And yeah, we will talk about it in a few moments. You already saw there was something called ARC42. That's a standard structure which was founded 20 years ago from Gernot Starke and Peter Ruschka. And it's like a wardrobe where you have some compartments where you put your content in, and it helps to have the structure to know which information goes in which compartment, for example. You don't have to use all of these informations. I don't go too much into detail here, but we will see some more of these. And in the first, it may be a bit overwhelming to see all of that, so it could be difficult to keep track of all these compartments. But actually, software architecture is not that complicated. In my opinion, there are two methods of software architecture, two sides of the coin. We have on the left-hand side so-called requirements, or our quality architectural goals. On the other side, we have kind of solutions, our decisions. And we want to talk about software architecture documentation. I have just brought you some of the ingredients for the left-hand side. There are maybe things like the context view, the system context, or a mission statement, or the constraints for our software architecture project. And of course, the most important part are the quality goals, the quality requirements, some things like maintainability, performance, usability, and so on. And these are the base. We have to know about these requirements, and then from that we have to follow to our solution strategy, and there will some decisions we have to decide. Maybe we also document them with ADRs, architecture decision records. We have to decide about architecture styles, patterns, about technologies, about decomposition, of course, and maybe we have kind of a big picture in our architecture vision where we see how architecture should look like at the moment. And all of that information is also part, or can be part, of the ARC42 template, and you will find it in the first 4 chapters. And yeah, we will see some more chapters in a bit. Okay, that's the very first parts of my idea of documentation as code. We already saw there are some text files, some lightweight markup files. And of course, everybody of us already knows Markdown. Markdown is a very nice, standardized, easy markup language. But it has some problems. The feature set is very limited, especially for a more complicated architecture documentation. You will miss some things like table of contents, like tables, like includes, or integration of planned UML, and some more. And there are some dialects for Markdown, but it's not that standardized anymore. So I would recommend to use not Markdown. You can use it, it's no problem. But if you have a software architecture documentation, have a look at AsciiDoc. AsciiDoc is also similar to Markdown, but has already has the same powerful syntax, especially for technical documentation, and has a very or is very rich of out-of-the-box features, and there are no dialects, and it's written in Ruby, but you can also use it with Java, with JavaScript, so it's quite easy. And we won't see any AsciiDoc snippets now. Maybe in this talk there will be some, but if you have some more questions about AsciiDoc, let's talk about it on the hallway track later. And there's also Alexander Schwarz here, another speaker, fellow speaker. He's also the creator of the AsciiDoc plugin for IntelliJ, so maybe you can also find him if you are interested in AsciiDoc and some more information about it. How does a basic Docs code process look like with AsciiDoc and with Markdown as well, actually? We have, of course, our Git repository where our solution architecture documentation is stored. Maybe it's just a solution RDoc, it's only one file, but of course there could also be more. We already saw that it's easy to decompose our documentation. Then we have tooling. In that case, we use AsciiDoctor. AsciiDoctor is a more modern implementation, interpreter of AsciiDoc files, which generates hard HTML, but also it's possible to, with some plugins, to generate, for example, PDF. And with diagram plugin, we could also use diagrams as code. We will talk about that also in this talk in a few minutes. And it's quite easy to have, for example, Arc42 integrated. There's quite a few templates which you can just download from the Arc42 web page. And then you get some more files and these nice decomposition, chapter 1, chapter 2, and so on. And this picture, please remember, we come to that back later. There is a bit more sophisticated approach. It's the easy one. You can just use AsciiDoctor from the command line. You can, of course, integrate it with Maven and Gradle, but we will come to that back later with more sophisticated tooling, of course. Let's go to the next topic, and the next topic is about images. How can we efficiently handle images? Maybe we could, of course, use kind of bitmap images, but it's cumbersome. So what are better ideas? And there's a phrase, it's called "a picture is worth 1,000 words." And yeah, how is it easy? How can we easily visualize complicated issues and use images instead of lots of text, for example? And there's an analogy to the construction site, to the where I come from. So I'm also a civil engineer, and there are also kind of views, kind of sectionals, kind of floor plans. And actually, these are different perspectives and levels of abstraction on our model, the house, which will be built later. And we also adapted this idea in the software development, and we have kind of views in Arc42. There are these 4 views. We will see some examples. There's the system context, the context view, building block views, the runtime view, deployment view. All of that goes back to the origin of Philipp Kruchten. He invented the 4+1 architectural view model. And yeah, that was his idea of describing architecture for software-intensive systems with multiple concurrent views. This 4+1 view model is not the same as the 4 views we already saw, but it's not that much different. There are the building block views that's called logical views. We have some deployment views which are not part of the 4 views. The system context is missing, but it's part of the building block views here, like in C4. Then we have runtime views, and we have the deployment view. And the +1 is just use case diagrams. So that's the idea behind the 4 views we use today, maybe in Arc42 or also in C4. We will see some examples. Let's come to some examples for the views. Let's start with the context view, which is just an overview about our system. The system itself is a black box, and we see the users, and we see some external systems, the actors, which we have, for example, to implement use cases for, or where we have to implement some interfaces to external systems, for example. When we go one level deeper, then we have the first building block view. That's a white box view then, where we can see the first level of our subsystems components. That could be, for example, also a UML diagram. In that case, it's a component diagram. The example here, and I forgot to put the source on the slide. It's an example from a book, from a German book. But there's a website, it's also in English, so if you're interested, it's called DocChess, D-O-K, and chess, the chess game, docchess.de. So please have a look if you are more interested in, some more informations. So that are the first views, the system context, the context view, and the building block view. There could be more levels. So the building block view, we could maybe look a bit deeper in the subsystem of engine, then we get the next level, but I don't have an example for that here. Let's go to the third view that shows interaction between our static components. There are different kinds of diagrams, like sequence diagrams or workflow diagrams, activity diagrams. In that case, it shows how the chess game works when a player moves a figure on the chess game board and the computer engine has to calculate the next step, the next move. And the last one of architectural, one of the view of the 4 architectural views is the deployment view. It's a quite easy one here, I know, but there are some better examples also on docchess.de, and of course, when you look for deployment diagrams, deployment views in the internet. And actually, this diagram just shows how our application, how the different artifacts are deployed on our infrastructure, maybe also in the cloud or on premises, wherever you deploy your application, your software. You can all fill that, of course, in Arc42, or you file it in Arc42. There are chapter 3 for the context view, chapter 5 for the building block views, 6 and 7 for runtime and deployment views. And I already talked a bit about C4. I think many of you already know C4. C4 is from Simon Brown. It's not quite different, not that much different to the 4 views in Arc42, but it's a bit different approach how we zoom in from the very common context view down to more details. And Simon Brown always compares it to or sees diagrams like maps, where you have the map of Europe, which is the context view. It's a kind of a bird's eye view. Then he just zooms in and gets a so-called container view. Then he goes in a bit deeper. Then he gets a component view, and then he is on maybe the way where he lives, which is the last C. The 4 C's stand for context, container, component. The last C is for classes and code. Actually, only the first 3 are interesting for C4. The 4th C is just if you need some more details, then you can just have a class diagram for some implementation of a design pattern or something like that. So if you've never seen C4 before, then just go to the codingarchitecture.com c4.pdf. It's not just these 3 diagrams. Actually, these 3 diagrams are part of, or you can also find them in the classical 4 views. There's a context view, and in that case, we have 3 levels of building block views. But there are also kind of runtime views. He calls it dynamic diagrams, and there are also deployment diagrams. So all of the views, the 4 view model is there as well. So if you use Arc42 or if you use C4, it doesn't matter. It has to fit to your project. You can choose. You can also have your own idea of a structure, but to have a kind of structure helps not only you, it helps also your teammates, or if you have to change projects, then it's easier to get into some new documentation if there's a kind of a structure. So we talked a bit about these structure ideas, but what about tools? And we are still talking about diagrams and how to efficiently handle diagrams and create and of course manage diagrams. And I think there are main kinds of tools. There are the conventional tools. I just brought some examples: Microsoft Visio, Microsoft PowerPoint, Adobe Illustrator, so that's kind of vector graphic tools. And of course, in software architecture, we also have kind of model-based tools like Enterprise Architect or Magic Draw. Sometimes you have to use them, but maybe it's not often that case. So they are quite expensive. They maybe are not lightweight, and especially the model-based tools are a bit complicated to use. So I would recommend to use lightweight free tools, and the best example is Draw.io or diagrams.net. So there are two names for the same tooling, or Wyatt, or also these online collaboration whiteboard tools like Miro, Mural, and so on. And the last one I would recommend, which you can also think about, is the diagrams as code approach. There, of course, you have already heard about PlantUML, I'm sure, but maybe if you are more from the JavaScript community, then you maybe have heard about Mermaid.js, or there are some other very interesting libraries for diagrams as code, Vega Lite. And if you want to explore all these diagrams as code tools, then please have a look at Kroki. Kroki is very cool. You can just try out about 25 of these diagrams as code ideas. PlantUML, Mermaid is maybe the most famous. They are the most famous ones, but there are a bit more and quite interesting, which maybe fit a bit better for your needs, what you have to document to where do we have to create a diagram, for example. So I already showed you which, my opinion, is the best. So I made kind of a ranking. I think if it's possible, then let's use the diagrams as code approach, because it fits well to the documentation as code approach. You have just text which you can understand, which will be rendered to nice diagrams, and which you can just put in your Git repository, where you can have a history, where you can just compare to an older version. That's very easy. Of course, it's not the case that you can always use tools like PlantUML, especially for more complicated diagrams. But then just fall back to these lightweight tools, Draw.io, and we will see some more examples in a few minutes, is very sophisticated, I think, and can, of course, use them as well. And you only need, maybe for very special requirements like model-based procedures, then you can, of course, use them if you need to use them, or if you need some functionality which is not provided by the diagrams as code or like the free lightweight tooling. So let's come back to this diagrams.net or Draw.io. That's, in my opinion, the most interesting tooling here. If you have to use kind of a WYSIWYG tool, if you can't use diagrams as code. And in that case, Draw.io is very compatible. You can use it as a standalone application. You can integrate or can use it inside the browser. There are also plugins for wikis like Confluence, for example, and also for IDEs. We will see that in a few moments. And it's very easy to just, they are quite feature rich. So you can just, especially for software architecture, you can just put some boxes and lines, and that's quite fast to have a very efficient way to create some nice diagrams with colorful diagrams. So they don't look cheap, quite nice, I think. And there's a very, very useful feature of Draw.io, and I know, or I think not everybody knows it yet, so you should know it. There is the possibility to just use bitmap formats with Draw.io. So you can just store your Draw.io diagram as a PNG or as a JPEG, But if you want to edit it later, then you have a problem, of course, because bitmap is not editable again, or not in that way you want to edit it, because you have a vector graphic actually. But they have this very nice approach to just put the vector graphic information in the metadata of the bitmap file, and then all the time you can just open it again, and it's much more easier to have a PNG to embed, for example, in a web page or in Confluence than, for example, if you have a SVG, which is also kind of possible, but if you have some customized vector graphic format, which uses, for example, Visio or PowerPoint. And that's a very powerful feature, and if you haven't tried it, you just have to name your file context view, in that case, .dio, .png, and then, for example, if you use IntelliJ and there maybe you have already the Draw.io plugin installed, and it just opens the Draw.io editor again, and that's very easy. You can just move your boxes and create a new one, save it again, and then it's already in the preview with the new version, so you don't have to export from your vector graphic file to some bitmap file and so on. So that makes it much more easier to integrate your diagrams in your workflows, in your text documents, for example. So that was the first idea I wanted to show you. Then let's go to diagrams as code, and I have brought you a very simple example of a sequence diagram. And in my opinion, sequence diagrams is the best example for planned UML. Of course, planned UML, as the name already says, knows a lot of UML diagrams, so it can also create component diagrams and class diagrams. And if they get bigger, then because of the automatic layout, not always the result will suit you. So maybe it's better if you have a kind of a structure way, like in a sequence diagram, or if you have smaller diagrams, then it's easy to have tools like planned UML. In that case, we have the result from the diagrams as code, source code would be generate these kind of picture. Maybe it's a bit boring, but you can customize all that this output, so it's could be much more nicer. Could be look a bit nicer if you want to customize it. And the friend of mine, Ralf Müller, I already mentioned him, got this challenge to just use planned UML for this bit more complicated architecture diagram. So it was for $15. Somebody at Twitter 6-8 years ago asked if somebody could also try to use planned UML to generate this picture. And Ralf tried it, and he succeeded. So if you're interested, and just use this QR code, and I will also provide the slides later, so can I have a look at the slides later, then can look how he have done this result. And there are some possibilities to give planned UML some hints where the boxes should be, on the right, on the top, on the bottom, and that's the way how it looks not the same, but quite similar to the source. And remember, if tools like planned UML or other diagrams code is not possible for you, then you can always fall back to other toolings like Draw.io, which are also very easy and good integrated in our tooling landscape. And if you are using diagrams as code, there is another very interesting tool from Simon Brown. So it's based on C4, the C4 model. It's called Structurizer, and it's a kind of a DSL where you describe your software architecture in a text file. I think there are also DSLs for Java, but I'm not sure about in a moment. And then from that DSL, domain-specific language, you can just create different views based on the C4 idea. So there's a context view, a component, container view, and so on. And that's very powerful because you only have to maintain this model file, and you can just generate the changes in a new version of your diagram without changing different diagrams, which maybe if you have to rename some component, then you have to look where this component is in your different diagrams, and that's maybe a bit cumbersome then. Yeah, and I already mentioned Kroki. Please have a look at that. It's a very powerful server which is available on the internet, but you can also try it for your own. For example, it's open source, and you can just install it in your local network, in your company, as a Docker image, for example. And there you have about 25 diagrams as code libraries, so you can just use it to explore all of them. And then you have the possibility to just put in some diagrams as code input code, and then it generates the picture from it. And on the bottom, maybe you can't see it, or I hope you can see it, there's the URL, which you can use to just embed this image in your documentation, for example. And of course, if you have it on your local environment in your company, then all information keep secure in your environment, and nothing goes out to the whole internet in that case. So many cool ideas. I hope some of them are new to you and you can try them later. Let's go to the last chapter for now, and it's about tooling in common. And tooling, I mean, I don't want these switches between different applications, from my IDE, text editor, to the browser, to tools like PowerPoint and so on. And let's start with a very common tool, which is in every company, I think. And wherever I go, Confluence is already there, and I'm not sure, but maybe you know the fable of the rabbit and the hedgehog, where the rabbit and the hedgehog make a race, and the hedgehog is already there when the rabbit, which is much more faster, comes to the finish. But the hedgehog, he's quite smart, and his wife is on the one side and he's on the other side, and the rabbit just races from start to finish, but doesn't notice that there are two hedgehogs. And for me, when I come to customers, I'm in a consulting company, so I always, or most of my time, are working with customers, and Confluence is already there. And I'm a big fan of Confluence. I'm a big fan of wikis, but wikis is not a good idea, I think, for software architecture documentation. A friend of mine said wiki is the place where documents go to die. If you have looked for some information, if you want to find some information in a wiki, then you will know what I mean with that. It's not that easy to find informations which are already in the wiki. We could also say wiki stands for where information kills itself. Maybe that also describes it best. So don't use wikis for software architecture documentation. It's okay, you can use it for ADRs, but not for the whole architecture documentation. And remember, most of us are developers, and we already have a very, very good and very powerful tooling. It's called IntelliJ, Eclipse, Visual Studio Code, or whatever tooling you are using here. And I want to speak about, or want to show you some examples of IntelliJ, which is with the plugin system, very powerful when you integrate, for example, the Troy-O plugin, the AsciiDoc plugin, the Plant-UML plugin. Here in that case, I have the AsciiDoc plugin or AsciiDoctor plugin. There you have some syntax highlighting. You have auto-completion for commands. You have auto-completion to look up files if you have to integrate your images or embed your images, for example. Then you have auto-completion if you are using variables. You have kind of a document structure, which may help if it's a bit more complicated document with some different levels for headings and so on. There's also kind of a section folding, which helps to just make the document a bit more readable for when you edit it. And there are kind of live templates, so if you use the same feature all the time, then you can just use live templates and generate some content. And that's only the tip of the iceberg. There are some more useful plugins, like the Troy-O plugin, And I already told you, when you save or if you create a new image file, let's call it diagram.dio for Troy.png, then you can just open it, and if you have already installed the diagram, the Troy.io plugin, then it's quite easy because it opens the whole Troy.io functionality, and you can just edit your diagram, save it, and embed it again, or it will be embedded again, of course. So let's go back to the basic process, how we manage or how we process our documents, which are as Markdown or AsciiDoc files, and we want to get some results in PDF, HTML, and so on. And we already saw that a very easy example, and there's a bit more sophisticated way. It's called DocToolChain. There you have also kind of easy installation process. So want to try it, it's just a matter of download a shell script, and then it uses Docker, or there's some magic behind it, and it downloads all the needed requirements. And then you also, maybe it's a bit dark, but there's the arc42 structure, for example, which you can just download and use it. And if you, for example, have Excel files, input from Excel files, you can just export them to CSV, comma-separated values, and then you can just integrate them. And there's also a bit more powerful way, because there's a plugin which exports the Excel file to AsciiDoc, which also preserves the colors and the column width and so on. And these are only a few examples for the very, very many different input formats, and you can also write your own. It's easy to extend. And on the other side, there are many output for options, especially if you still need Confluence, you could just publish your documentation, which you are writing in AsciiDoc, for example. You can finally publish it to Confluence so that everybody in a company has access to your documentation. So that would also be nice. Yeah, and there are some more tools. We can't go deeper, but I'm here the whole day, so I'm interested which of the tools you are using. Maybe you have some good ideas for me, which I can take home. So please come in the hallway track to me, and let's discuss some more ideas. And we have to come to the end, unfortunately. I have some more steps in my maturity model. There is the step of the continuous documentation, which means we create automatically documentation all the time. So if we deliver a new version of our software, we also deliver a new version of our documentation. We have to edit again, maybe, that's in German, sorry for that. Then we have to review. We can integrate it in our review processes, in our pull requests, for example. And we can, of course, integrate the feedback of our readers, and we should do that then, because documentation is as good as it is also used. It's used effectively. And the last step is about putting it all together to create a very lively executable documentation. And the idea is to have a documentation where, for example, we have kind of different artifacts, for example, for different target groups. We synchronize delivery to provision all the time the current state of our documentation. We integrate architecture rules and tests into the documentation and execute the documentation. Actually, we execute the tests, but they are part of the documentation, so we have some kind of executable documentation then. We can also embed API calls and snippets, code snippets in the documentation. And maybe you've seen in IntelliJ, you can just click on the run button, and then it just calls that snippet, for example. And of course, we have to use the feedback of the users and get better then. So let's wrap it up. In my opinion, documentation helps a lot if you have a good documentation, especially for software architecture, because it's all about transparency. We have lots of stakeholders in our software architecture projects, and especially the know-how transfer, if you have a good documentation, is important. And in my opinion, and that's more fundamental thinking of software architecture, it really helps if you have a systematic approach doing a software architecture, please remember there are these two parts, the requirements on the one side and the solution on the other side. And if you only have solutions and have never thought about requirements, then maybe you should have a bit more systematic approach there. If you're interested, the company where I come from, Embark, also has the other training company. It's called So Creatory. So have a look at that. Maybe we see us again in a training. And the slides I will put in a few minutes on the website embark.de/download. You will find them there, and I will also give it to organizers. So thank you very much for being here, and have a nice conference. If you're interested for German-speaking people, there's also about this topic. There's a so-called cheat sheet, and we call it Spicker. There are a few of them are here in the front of me. Please come to me. And if you have some more questions, please also come to me. Thank you very much.